Hi guys, welcome to my YouTube channel. In today's video lesson, we are going to be continuing from where we stopped in our last class on dimensional analysis. In today's lesson, we are going to be explaining some questions under dimensional analysis. Okay, so in our last class, I said that dimensional analysis has various importance in physics. For example, dimensional analysis can be used to determine the correctness of an equation. For example, whereby an equation is correct or is not correct, you can be able to use that dimensional analysis to explain or to determine whether the equation is correct. And also you can use dimensional analysis to derive an equation. For example, you are in an examination hall uh, and you are asked to calculate some questions, maybe in physics or in other course, and you remember the variable. You can easily use this dimensional analysis to what to derive the equation. Okay, let's continue. So obtain the dimension of the following. Number one, volume. We all know that when we talk about volume, we deal with three things. It can be what? Length times breadth times height, right? So volume is what? Length times breadth times height, alright? And if you look at this length, if you look at this breadth and this height, all of them they are what? They are length, right? And in dimension, we say length is represented by L. So we are having L, and also breadth is also L times L, height is also L times L, right? That means we have 3L. So our dimensional for volume will be what? L cube. So moving to the next question. Obtain the dimension for speed. Now speed. Okay. What's the formula for speed? The formula for speed is uh, distance over time. And we all know that distance from our last class is also what? L, and time is represented by what? By t. So we have distance, which is what? L over what? Capital letter T. And according to law of indices, whenever you have something like 1 over t, it is also equal to t raised power 1. That means in this scenario now, your answer will be what? LT raised power minus 1. So for force, C, what's the formula for force? Force is what? Um, mass times what? Acceleration. That's mass times acceleration. And we know that the dimension for what? For mass is capital letter M, right? And the dimension for acceleration. Okay, let's solve acceleration here. Now acceleration. We know that acceleration is what? Velocity over what? Over time, right? And we know that velocity is what? Displacement over time. So from here, from this velocity, you can be able to get this acceleration. From this acceleration, you can input it here to get your what? To get your force. So from velocity, distance over time, the d is distance. You can represent it by what? By L. While the time is t, you can represent by t. That means your velocity here is L raised power what? Minus 1. So since you have gotten your velocity here, you can input it here in this acceleration and say that your velocity now is L raised to power minus 1 over what? Over t, right? So in this scenario now we are having 2t, one is beneath while one is above. According to law of indices, if you have if you have two bases that are having different um, power, if it is a division, you are going to what? Subtract. But if it is an addition, if it is multiplication, you are going to what? Add. For example, in terms of a raised to power x multiplied by a raised to power y, your answer will be what? A, because there is multiplication here, this power will be what? Will be added as x plus what? Plus y. But in this scenario whereby we have a x divided by a y, we have something like this: a x minus y. So in this scenario now, because we are having t here, this let's evaluate this: t raised to power minus 1 divide by t, there's an invisible one here, right? So it will become t, since it's multiplication, this and this, there will be what? Subtraction here, and that's minus 1 minus 1, and you know that minus 1 minus 1 is what? Minus 2, right? That means our acceleration will be L t minus 2. These are our final what? Acceleration. So since we have gotten acceleration, we can easily input the acceleration here. You now say L t raised to power minus 2. That means our force is what? M L t raised to power minus 2. Okay, let's move to what? Work done. Now do. Let's work done. And the formula for work done is what? As force times what? Times distance. Work done is what? For example now, I want to carry something up, right? So in the process of carrying that thing up, I use force, right? And there's a distance in which that thing is being moved. So that's what? The distance. So for a work to be done, there must be what? A force that is applied to move that thing and to a particular destination, which is what? The distance. So force, we have calculated force here now as mlt raised to power minus 2, and d, we all know that d is what? Distance. That means mlt raised to power what? Minus 2 multiplied by what? Multiplied by l. And like I said before, if you are having the same base but different power, if it is multiplication that is in between, what you add, there's one here, there's also invisible one here, so you can easily add them together. You have mlt ml to t raised by what? 2. That's what? That's a dimensional for what? For work done. So let's move to gravitational constant. Okay. So the formula for gravitational constant, you can get this formula from the law of Newton, right? Which says that the force is what? Is directly proportional to what? The product of two mass, right? That's M1 and what? And M2. And indirectly proportional to what? To the square root of the what? Distance between them. That's what? R square, right? So if you want to remove the what? The sign of this proportionality that is in this place, you will introduce a what? A constant. And the constant is referred to as what? The gravitational constant, according to Newton. So F is equal to what? G M over what? R square. So now, since we are looking for what? For the gravitational constant, the dimension. So what we are going to do is that to make the G the subject of the formula, so that it will be easy for us to determine the dimension of the gravitational constant. So let's make G the subject of the formula. Now we can say F is equal F over 1 here, and cross multiply so that we can isolate this G from the rest. So we can say G M equal to F R square. Divide both sides by what? MM over MM. You can say this one divided by this one, and you are isolated with G equal to what? F R square over MM. Right. So from what we have done far, we have calculated for force. We know distance, and M is what? Is our mass. So from there you can easily calculate for the dimension of this gravitational constant. That's G. Our force here is what? Is what? M LT raised power 2 minus 2 multiplied by R is radius, which is also what? A distance. That's L raised power 2 over M. That's what? Our mass. Here now we have two mass. You can easily combine it together. I have M squared. Right? But if you look at this equation, we are having M here. We are having 2M here. So you can easily cancel one out. And also we are having L here and 2L here. Since they are in the same place, you can easily add them together, and the addition is based on the fact that there is multiplication in this place. So our G is now L, this one plus this one will be 3. That's L minus 2 over what? Over M, right? So like I said before, if you have something like M over 1, it should be what? It should be M raised power what? Minus 1. In this situation now, you can say M raised power what? Minus 1, L raised power 3, and what? T raised power what? Minus 2. That's the answer. Okay, let's move to the next one. That's what? Electrical resistance. So we know that according to Ohm's law, right, we are having V is equal to IR. So this V is not velocity, is what? Is our what? Potential difference. Why this I is our current. Why this R is our what? Electrical what? Resistance. So for us to get this R, we are going to do some calculation. Let me say calculation, because from other formulas you can easily get this R. For example, now we are having power. electrical power is equal to what? I square R, right? And you know that power is what? Work done over what? Over time taken. Since we have calculated for work here and we know time, we can easily relate it to this formula, and we say I square R, right? From this formula you can easily isolate this R and what? Calculate for the dimension. Let's isolate it. That means you are going to do cross multiplication. Our cross multiplication will give us R square RT equal to what? W. So in isolating this R, we are having R equal to W over I square T, right? This work done, we have calculated for work done in this place. So we can easily put that our work done is what? L square T raised by what? Minus 2 over I. From our last class, the dimensional for R is what? Capital letter I, right? We can say our I here is what? I square, and our T here is what? Capital letter T, right? Okay, let's express it to what? To the lowest form. So we are having T here, we are having T here, right? And like I said before, if you are having the same what? Base but different power in indices, and there's a division that is separating them, you are going to what? Subtract. That means it will be like T raised by minus 2 divide by T raised by what? 1, because there's an invisible one here. So we are having T raised by minus 2 minus 1. That means we are having T raised by what? Minus 3. Right? So you can say is what? M L T M L square T raised by what? Minus 3, because there's this R, this I is in the denominator. If you want to bring it up, it will become I raised by what? Minus 2. That's our what? Our last answer. Okay, let's move to the next one. Okay, in this particular question, you want to calculate the period of simple pendulum. For example, you are in an exam condition and you forget the formula that is being used to calculate the period of a simple pendulum. And you remember that in an experiment of a simple pendulum, the period is always proportional to what? To the mass, the length, and what? And the gravitational what? Gravity. But the proportionality, you don't know that whether it's directly proportional or what? Inversely proportional. Since you have known that the period of the simple pendulum depends on these three things, right? You can easily derive the formula for calculating what? The simple what? Pendulum. Okay, let's play this place.